Test, test.
No, yeah.
Well, it could be.
I don't have a clicker, but you can just press the arrow for the next one.
Well, perfect.
I think we're gonna wait just a few minutes to see if anybody else comes. Just like 2 more minutes.
Yeah, you got it. You just tell me when.
Okay.
Well, this is gonna be really okay. I think I'm gonna go stay shut and put all of them back. I always love when I have a shotgun, yeah, I just want to. But definitely, I also try to.
The Rosetta Stone, that one step.
There's gotta be something that's not about sharks. And then it's
Right.
for whole school to go and chat. Another one is called
They have these things like this all the time.
That's the tough thing I want for me.
It's a little wood table.
Yes, on the right hand side, not the left hand side. They would make it fire or something.
You're not.
Just pretty good.
Or you already done it on
But it was worth it, because they had keys. And then,
Yeah, that's what.
Yeah.
but they got wiped out with the stroke.
The owner of Ben and Mary's, Ben Richardson.
Does Yum offer like full scholarships?
Generation
Or
back
like,
from there. And his son is the biggest
I mean, there were
swordfish
probably-
fisherman. He's a very well known, but I still don't bigger than all they have. And
I've seen more people
so kind of the bio nature, like a marine science. I've heard of that. Yeah.
Yeah, because I understand.
Got it. Good.
Yeah.
No, she's in a easy that.
There are more places to find.
You went wild.
As far as this goes. But, yeah, like, you know, it's like cool, but like, crazy. So I was looking at like,
Target the biology.
yeah, if I do, maybe you have to, and then like.
They're not that good. No, it's.
Yeah.
Nobody would have had kids on.
Yeah. But especially if there's a virtual option, like, I'm not sure.
Oh.
99 out of 100 times, they're not.
We're here.
That's why it's recording. It's streaming, it's on. And there you and I are going to be.
In person.
Even if you take records down, or go live, and Facebook has.
Raise my hand.
Just because it pops up as a notification. So, I think the max we have is like 10 or 11 people. People usually like join in for a few minutes, and then it's about back in.
I want to.
I know.
You're watching it on their phone.
The nice thing is that the software we put in records it, and so it's always forever. So that's really nice. Yeah.
Oh, there's something.
It's always there.
No. Just try. It's gonna be fun. Y'all are scary.
I think we're ready.
We usually have 8 trickle, well, they can trickle if they do. All right, hello everybody. I am not sure how streaming is working for streamers, so sorry if it's bad, but enjoy. And folks who are here, is there a not complete darkness option, or are we like fully dark? Oh, the ones at the back are great.
It's only one switch.
Oh, I got you.
So
Can you all see it with the lights on?
Do the side switch, though, the side.
With the bad lights, the less light?
less light?
Yeah. Can you guys still see it?
Yeah.
Well enough? Cool, great, because I can see you. Talk a little bit more. So, hi, I am Dr. Catherine McDonald. I really prefer that you call me Catherine, but if that is uncomfortable for you, Dr. McDonald, also fine. I'm the director of the Shark Research and Conservation Program at the University of Miami, and I'm really excited to have time to chat with you tonight about some of the work we're doing and about sharks more generally. I structured my talk so that I will hopefully have time for a bunch of questions at the end. So I would love for this to be a little more conversational. And if as I go you have a question, don't be shy about interrupting me. We're a small group here. I'm a classroom teacher, so I'm very used to fielding questions and coming back to my point. And I prefer something a little more interactive than everybody just taking a nap while I yammer on for 40 minutes. So, as I said, I'm the director of the Shark Research and Conservation Program at the University of Miami. I have been at the University of Miami as faculty since 2018. I took over this program about a year ago. I have 15 years of experience working in the field with sharks, and I currently spend about 110 days a year at sea. I know that I look young, thank you, I'm flattered, but I have been working in shark science since I graduated college, which is about 15 years ago.
Good sunscreen.
Yes,
Yeah.
everybody should wear a lot of sunscreen. And a hat. Hat'll help you. I study shark and ray ecology, biology, and conservation. So I'm mainly a conservation biologist and ecologist, but I'm interested in the application of the data that I collect to conservation and management. So when we're designing projects, we're thinking not only about the questions we want to answer, but also about what they might mean for how we think about protecting and managing shark populations, especially here in South America. I also study tropical marine ecosystems. If you care about sharks, you have to care about the ecosystems that they live in, because no ecosystem, no shark. If you care about big sharks, you have to care about small sharks, because in fact, small sharks are a meal for a big shark. And in the absence of healthy small shark populations, you won't see those apex predatory sharks that we get on Shark Week. So the first shark that I ever fell in love with is a bonnethead shark, and we're looking at one here that is sporting one of our handy mark recapture tags. So this animal's just been through a workup, and he's on his way about his business. Those mark recapture tags are a key part of our research program, and essentially they are just a little plastic covered tube with a unique ID number. So the number on that tag attaches all of that shark's samples that we took from him to his measurements and other data, and if we ever recapture him, we'll be able to connect new samples back to his original capture, and we'll be able to connect where we caught him the first time to where we caught him the second time. This is the lowest tech version of shark tracking, and it works great for small sharks and also for situations where you can put out a lot of tags. So for instance, this is how NOAA answered a lot of questions about habitat use and growth before we had modern satellite tag technologies. They put out, I think to date, they've put out more than 70,000 NOAA cooperative tags. And that's how we first learned that sandbar sharks were crossing the Atlantic. That's how we first learned a lot of what we know about the growth rates of different shark species. So today, I mostly work with bonnetheads in situations like this, but I first fell in love with them in a situation like this. That's a little bonnethead out on the beach. So my first experience with a shark in the wild was somebody catching one beach angling when I was at the beach with my great-grandparents in South Carolina when I was a kid. And this guy pulled it up on the beach, and he must have not been a very experienced angler, because he very obviously didn't know what he wanted to do with it and was feeling pretty uncomfortable even about trying to handle it or dehook it. And all of these other adults on the beach got really worked up about how these sharks had been in the water with their kids And this thing was like that. And even at 8, I kind of walked over and just was snooping around a little bit, and I was like, if somebody's in danger here, I don't think it's me. I don't think it's those of us who were swimming. This guy's in trouble. And so I had a lot of sympathy for him. And that never really left me. The way that I saw that little shark as somebody who was being misunderstood and unfairly handled and under threat is really how I still see them up to the present day. So we're
How
gonna.
big do bonnets get? Because I've never seen one bigger than 18 inches.
No, they get. I mean, down here we don't really catch it any bigger than about that. But as they move north, their maximum size gets bigger. So they get them in the 4.5 foot range up that way. Although this one was also not very big. So we're going to do a little background on sharks, what they are. This may be review for a lot of you. So feel free to ask me some harder questions because I would love them. So sharks are ancient cartilaginous fishes. And by cartilaginous, we mean what? They are structured only with cartilage, no bone. So that cartilage can be quite heavily calcified to the point that we wouldn't see a big distinction between it and bone, right? Their spines are very heavily calcified in a lot of cases. But all of their internal structure is made up of cartilage rather than bone. Cartilage has the advantage of being a lot more flexible than bone, right? Think about the tip of your nose, your ears. They can bend without breaking. But it also has the disadvantage of being a little bit less protective, right? Something wants to hurt my internal organs, it's got to break my ribs first in a lot of cases. For a shark, impact injuries and things like that can do a lot more damage because they don't have the same level of internal structure and protection. And of course, one of the biggest advantages of cartilage is it's lighter than bone. So sharks are able to better manage their buoyancy than they would be able to if they were bony fish, which is important for them because unlike most bony fish, they don't have swim bladders to help maintain their buoyancy in the water. They rely instead on a big oil-filled liver. So there are more than 530 species of shark on our planet, and they are incredibly diverse. Normally, well, I'm just going to do it. Will you all name some sharks for me? The first ones that pop to your minds. Great white. Hammerhead. Tiger. Bull. Nailed it. Those are almost always the first 4, right? Those are those classic shark week sharks. But of course, with more than 530 species, the average shark on our planet is between 3.5 and 4 feet long, kind of brown, a little bit dumpy, and it lives in the medium deep sea. So when we think of sharks, we're actually thinking about a very small group of 10 or maybe 15 species of the largest predatory animals, and not the group as a whole, which is overall much smaller, much lower in the food chain, and much less potentially dangerous to people than the few who make the headlines. One of the things that they mostly have in common is that the vast majority of sharks are predatory animals. We include even our filter feeders, like our whale shark and basking shark, in that list, because what they are eating are tiny zooplankton, right? Very small animals that live in a planktonic state. But we do actually now have a couple, just in the last 5 years, that we've discovered are omnivores. The bonnethead shark is one of them. Bonnetheads not only incidentally consume seagrass when they're chasing crabs, but also consume it on purpose. And they appear to have a specialized gut microbiome that lets them digest it, with a similar digestive efficiency to juvenile green turtles. So it looks like seagrass is actually probably an important part of bonnethead shark diet. And it looks like phytoplankton, the plant part of the plankton, is an important part of whale sharks' nutritional needs as well. So the vast majority of sharks are exclusively carnivorous, right? They eat other animals and that's it. But there are at least a few that are complexifying that picture, and it wouldn't surprise me at all if in coming decades we discover that there are sharks with more diverse feeding strategies than we currently realize. And of course, when I say carnivores, I'm not just talking about they're chasing down big tuna, but also in a lot of cases they're eating small invertebrates or small fishes, depending on their body size. And when we get into their close relatives, the rays, obviously we get into even weirder prey, including lots of little worms and stuff. In general, sharks are slow growing and slow reproducing. And what we mean by that is it takes them a long time to reach maturity. And once they get to maturity, they can't carry that many offspring at a time. This feels really natural to us as humans, right? Because we're similar. For a lot of humans, it's 13, 15 years before a human reaches sexual maturity, and probably more than that before they're at their peak. And we can carry one, maybe a couple offspring at a time, but not really anymore. But for fish, this is actually extremely unusual. Most bony fish are what we call spawners of various kinds, so they can release millions of eggs at a time, creating a very large number of offspring. When we talk about this investment in their offspring, what we mean is a bony fish might create millions of offspring expecting only one to survive. A shark might create 3 offspring expecting only one to survive. It doesn't mean that it costs less energy for that bony fish to reproduce. It just means that each offspring costs less, right? Its overall reproductive budget can. But it takes sharks generally a long time to grow to maturity. The fastest would probably be about 1 to 2 years. The slowest is the Greenland shark, at least as far as we know, and the current estimate is that they reach sexual maturity somewhere between 125 and 150 years of age. So for them, it's going to be a very long process if you want to see them replenish their population. This is one of the biggest challenges for shark conservation, right? If we overfish fish by accident, we can reduce the amount we're fishing. They can produce an awful lot of offspring. In many cases, that overfishing has created a more favorable environment for the offspring, less competition with adults, less risk of being eaten by adults. And bony fish populations can often recover from overfishing pretty quickly. For sharks, that timeline is much slower. We're only now starting to capture in scientific data the benefits of shark conservation actions that were taken in the 1990s. So at least 10 years for many species to even reach maturity, and then quite a lot longer for you to start seeing the benefits of their reproductive contribution to the population. And then finally, when I say that they are ancient, I mean they are really ancient. We're talking 400 to 450 million years, depending on who you ask. And for some contexts, that makes sharks older than trees as a group. It makes sharks older than the supercontinent Pangaea. It makes sharks older than the North Star. So sharks have been on our planet for a very long time. And we now find ourselves in the situation of getting to make decisions about whether they are able to persist here in all of the places and all of the ecological roles that they have in the past.
Question.
Yeah.
When you say sharks reproduce, they don't spawn?
No.
So
So
how do they fertilize their eggs and release eggs?
I am already in so much trouble on how long this talk is going to be, but I'm very excited that you asked. So sharks are internally fertilized. So do I have a picture of this? Only maybe. Male sharks have 2 external claspers, right? If you flip a shark over on its underside, every shark will have a slit opening that it uses for waste elimination. That's called its cloaca. And the males will have paired claspers on either side of the cloaca. And it's not a penis, it's a modified calcified pelvic fin. So basically they've evolved a rolled up, hardened pelvic fin with species-specific spurs on the end of it that they can use to anchor that clasper in a female during mating and deliver sperm. Depending on how ancient the lineage is of the shark in question and its evolutionary strategies, the female can then do one of 3 things with that. In some cases, especially for some smaller bodied species, they're egg layers. So they will lay like a big, complex mermaid's purse kind of thing, right? If you've ever seen a mermaid's purse on a beach, that's kind of tied off to a reef structure, or it's under a ledge, and the pup can develop inside that before eventually hatching. Then we have sharks like nurse sharks that are what we call aplacental viviparous. So mom lays eggs into her uteri, but she doesn't have any kind of connection to those offspring. Those eggs hatch inside. She'll often produce unfertilized eggs for them to eat, and they'll grow to a larger size before she gives live birth to them later. But in those cases, right, unlike a mammalian strategy where we have a placental connection to our mother and she's breathing for us, she's taking care of waste elimination, she's providing nutrients, they have to manage all of that in the uteri and the oviduct. Sharks have 2 uteri apiece. And then in the most modern carcharinids, including most of the ones you just listed, although not all, they actually do have a pseudo-placental connection to mom. So they have a little umbilical cord, it connects to, rather than a belly button, they have kind of a throat button right here. And they're enclosed inside the uteruses in their own, what are called sarcophagi, because you can imagine that if you had a dozen baby sharks all connected by an umbilical cord, they'd tie themselves in a giant rat king of baby sharks and be really hard to give birth to. So they're kind of enclosed. It also helps if any of them are abnormal. If one of the pups dies, that sarcophagi will actually prevent it from poisoning its siblings in utero. I was once at a dissection of a pregnant shark where one of the pups was this like horrible little Voldemort thing that had died, you know, a long time ago. But the other pups were all healthy because they'd been partitioned off. So 3 main reproductive modes: egg laying in utero, eventually giving live birth, and a pseudoplacental connection leading to live birth. If you've been around for more than 400 million years, you've had a lot of time to figure out different strategies. But we think that they are among the first groups of animals to employ internal fertilization.
Oh, really?
And the males, shark mating is very unromantic, right? So a male would bite onto a female's side or peck fin flip her over. They are dominant claspered in the same way we are right-handed or left-handed. Male sharks tend to be right claspered or left claspered. But the clasper crosses the body for insertion. The clasper first lays out to anchor them, and then they use water pouches to force sperm into the female's oviduct before uncoupling. It's very quick, especially since for many sharks that have to swim to breathe, if you've got a mouth full of lady, you're not actually able to breathe at the same time.
So, I guess when they're in breeding time, it's very aggressive. The males are very males. Is there a lot of fighting? Do males kill each other often?
No, it's not so much dominance-based. It's usually females.
Have you seen this? Or
Yes. It's usually female selection related, so females will try to avoid a male that they're not too interested in mating with. At least in nurse sharks, which are the sharks we've best studied because they mate in very shallow water, the females can cup their pelvic fins to try to prevent the male from being able to mate. They'll move into very shallow water where he can't kind of easily follow. So there's some female selection. We also know for some species that as they approach mating season, female skin will thicken, in some species up to 7 times thicker than it is the rest of the year. And the points of males' teeth will lengthen. So there's a little bit of an arms race between the males and females in terms of being able to grip on versus being able to resist being gripped or injured in that process. But sometimes females do incur quite nasty injuries. We caught one a year ago who had a lot of scar tissue at the gills, where I think a male had just unluckily kind of gotten the back of her gills instead of her fin. But she was still kicking. So why do we need to worry about shark conservation? Well, we just talked about slow growing, slow reproducing, that matters. 37% of all shark species are evaluated as threatened with extinction by the IUCN. That is the highest rate of being under threat of any group of vertebrates except for amphibians, which are the highest at 41%. The average across all assessed life, and obviously there's selection for things that might be threatened when they decide what to focus assessment resources on. For all assessed life, the rate is about 28%. Sharks are mainly threatened by overfishing and unsustainable harvest practices. Here in the United States, the goal of our fisheries management is to generate maximum sustainable yield. So for sharks that are legally fished, the National Marine Fisheries Service's goal is to have us take out as many of those sharks as we can without compromising the population's future viability and the future availability of those animals as a resource. For sharks, that rate is always going to be much lower than for bony fish for the reproductive reasons we talked about, right? Bony fish can replace themselves much faster. A smaller number of females can put out the long-haul babies. Shark fisheries are pretty challenging to manage globally. Here in the US, I would say that we're doing a pretty good job for most, if not all, species. But in many parts of the world, Shark fisheries are pretty unregulated. The management resources may not be there to oversee sustainable fisheries. And as we've depleted other marine resources through overharvest, people have increasingly turned to sharks to kind of make ends meet. Shark is in general not a high value food for most people. Sharks osmoregulate, they manage their internal salts using a compound called urea, which is the same thing that makes your pee smell like pee. And so even living sharks don't always smell great. A dead shark, especially if it's not very fresh, definitely doesn't smell great. And so they're not a high value food item for their meat for the most part. Although in many parts of the world, they are a bulwark between poor fishing communities and hunger. And in those cases, obviously efforts to conserve them need to also account for the essential needs of people. Sharks occupy both apex predatory and mesopredatory roles. What it means to be an apex predator, you're at the very top of the food chain, right? A mesopredator, there's stuff that eats you, there's stuff you want to eat. I like to tell my students that being an apex predator is like being the tallest man in the room. It depends on who else is in the room. So even the most apex predatory sharks are great white, right, which is our largest predatory shark, is not the apex predator when orcas show up. And in fact, there's been a huge conservation struggle in South Africa as great whites have been increasingly having their livers ripped out and eaten by local orcas that learned how to do it. And we're like, hey, this is a pretty tasty snack. So when we talk about apex predators or mesopredators, we're always talking about them in relation to the rest of the ecosystem, and who makes up the rest of that system is going to just determine your position. So a shark that we might consider absolutely a mesopredator, let's say a lemon shark this big, right? We're 4 years old, maybe at this size. We're still pretty small. In very shallow water that bigger sharks won't go in, that might be the apex predator that's likely to be present most of the time in that environment. It doesn't mean that overall it's an apex predator, if that makes sense. Sharks are limited in their population size by the way that energy flows within ecosystems. So the rule of thumb for thinking about energy in ecosystems is that you lose about 85 to 90% of the energy at every trophic level. And what we mean by trophic level is just the steps in these pyramids. So to create one equally sized unit of sharks, it takes 10,000 units of whatever the base of that food web is. In this case, I've offered you plankton, but mangroves or seagrasses would also work as an example. So it takes a huge amount of plant productivity, which is drawing its energy from the sun, to create a much smaller biomass of small consumer organisms, mesopredators, secondary mesopredators, and apex predators. That means that the total biomass of sharks is always going to depend on the biomass of all of the levels below it. And that's why when we talk about harm to ecosystems or overfishing hurting sharks, it's not just about what sharks are we catching and taking out, but also how are we altering this pyramid in ways that change the amount of energy that's available to the animals at the top. And for sharks, the threat of that is different depending on your ecosystem. So for an apex predatory shark that moves long distances, changes in one of the food webs it relies on might not be essential, right? Like if there doesn't seem to be a lot there this year, just move on. And for small-bodied sharks that are pretty site attached, there may not be anywhere else to go if the ecosystem that they depend on is disturbed. We talked about this already, so I'm not going to spend a lot of time on it. But the term that ecologists traditionally use to talk about this difference between fast-growing, fast-reproducing animals and slow-growing, slow-reproducing animals is K versus R selected, right? And K stands for carrying capacity, right? The reason that they are such slow reproducers is that if they reproduced out of control, they would eat everything below them, and the whole ecosystem would sort of fall apart. And so there are evolutionary pressures that make them very slow to reproduce. But in general, they're characterized by large total body sizes, later ages at maturity, fewer, more developed offspring, and high rates of survival among those offspring. For some sharks, we know that that can be upwards of 80% of pups they give birth to surviving, which is vastly, vastly better than we expect to see for teleosts that are just spawning into the water column. Why do we care about sharks? Well, I don't know if I have to tell you guys who came out here on a Wednesday night, so I feel like I'm in a good position here. But one of the reasons that I think people should care about sharks is that in many ecosystems, they can serve as keystone species, which is just ecologist's way of talking about species that have a disproportionate ecological significance based on their biomass or abundance, right? How many of them there are, what total weight of them there are. Their importance is disproportionate to that. And in sharks, it's disproportionate for two key reasons. One is predation. Through their feeding activities, right, they serve to keep prey populations under control, but also to control things like illness and genetic abnormalities. When we fish, we want the most beautiful, healthiest, most gorgeous fish to eat, right? But when a shark fishes, it wants the fish that's easiest to catch. And so in a lot of cases, they are helping to shape genetic selection of the fish stocks that they feed on in ways that keep those stocks really genetically and physically healthy. And they also have behavioral effects on their prey species. So even where they might not be hungry, even where they might not eat a fish, a shark that's patrolling a reef is going to control what the fish on that reef feel like it's safe for them to do. And on reefs where sharks are present, you might have herbivores out all day nibbling on the corals, nibbling on the plants. And where a shark is cruising, they'll come out, grab a mouthful, and go back undercover because you don't want to get on the wrong side of that shark. You don't want to get caught too far away from your hiding place. And so those effects on animal behavior, even outside of predation, can play a huge role in shaping ecosystems. As we talk about marine ecology, we talk about top-down or bottom-up control of ecosystems. And in marine ecosystems, it's almost always both. Top-down control, the presence of those sharks shapes what animals are there and what they do. Bottom up, the presence of the bottom of that food web, whatever that primary producer, that plant is, that's creating all of the energy that's then percolating up through the food web, how much of that there is the thing that controls the shape and the structure of the ecosystem. And what we're looking at here is a bloom of coccolithophores, which are a kind of planktonic phytoplankton that we can actually see from space. Right? If you ever see a picture from space that looks kind of milky in the oceans, that's coccolithophores. So we know a little bit more about sharks than we did, or we've reviewed some things about sharks that we already knew. What about me, what I do, what's my deal? So the Shark Research and Conservation Program at the University of Miami does conservation relevant research on sharks and their relatives, so we also study rays. That research mainly focuses on diet and feeding ecology, so what are sharks eating, how are they eating it, how are they dividing resources between each other, right? So sharks do a fair amount of partitioning. This piece of habitat is mine, this piece of habitat is yours, or we use the same habitat, but I'm going to be more active at night, and you're going to be more active during the day. To manage competition, right? Because otherwise competition from an ecological perspective becomes wasteful. You don't want to put energy into competing where you can just divide and conquer. We study habitat use and we try to identify critical habitats. I'm especially interested in juvenile and small-bodied sharks habitat use and the importance of biscayne bay to those small sharks. Shark stress, especially relating to capture. Here in South Florida, recreational fishing is a much bigger threat to sharks than commercial fishing. Since 2016, recreational landings of sharks have exceeded commercial landings every year. And so understanding how even catch and release fishing affects sharks' fitness and well-being is an important component of managing those resources for the future. And I'm very interested in shark reproduction. So both what are important reproductive habitats, what do they look like, what do the hormonal profiles of these sharks as they go through reproductive events look like, and what kinds of outcomes do we see for those pups in highly urbanized Biscayne Bay. We also have an educational and outreach mission, so you can see a little bit of it up here, but for the vast majority of days that the Shark Research and Conservation Program is in the field, we have high school groups in the field with us. We usually have about 20 high school students on board on any given day. When I tell people that I study sharks, they normally imagine something like this. And I really enjoy getting to tell them that the sharks I study are more like that. We work with primarily small-bodied and juvenile sharks, although we do still catch some big and I do still enjoy the chance to see and work with them. My favorites are the teeny tinies. And when I tell people that I'm a marine biologist, they usually imagine that I spend my life in environments that look like this. Pristine, untouched by human hands, maybe one person has ever snorkeled there. And I really enjoy telling them that I catch almost 1,000 sharks a year in habitats that look like this. A big piece of our mission is trying to demonstrate the ecological importance of highly human impacted habitats, because it can be very difficult to get people interested in their conservation. When I talk about conserving Biscayne Bay, people tend to kind of be like, well, it's over for Biscayne Bay. Like, what are you even trying to do here? And up in this area, things are pretty dire for Biscayne Bay. You all have 90% seagrass loss up here in the northern bay in some places. Down in the central and especially into the southern bay, we see it in much better condition. And a big piece of that is we have more exchange with the ocean. And so we have less challenges with managing pollutants that are coming off of our urbanized coast. Just to give you all a little bit of a sense of the sharks we see here, we've got a big fat bull shark. She was actually pregnant, so she was a nice animal for us to get to sample, all the way down to tiny yellow stingrays that are about the size of a dinner plate, and our juvenile great hammerheads, which we're actually the team that discovered the first known nursery area for great hammerheads on the east coast of the United States, and it's right here in Biscayne Bay. So don't tell me Biscayne Bay doesn't represent critical habitat for some species. South Florida.
Tell us more about that. Where is this nursery for great hammerheads?
It's about 2.5 miles south of the Rosenstiel School, if you know where that is.
Okay. So that's like southwest, right around Stillsville, southwest Stillsville.
Yep, it's pretty close to Stillsville.
Okay. And like how deep?
12 feet.
And what does that mean? Why is that place significant? Why is it unique?
Great question. We're still trying to figure it out. It doesn't seem to me like a place that would be optimal for them. I mean, and it's very possible that they do range further south into less urbanized areas as well.
Is it grassy?
We've got some grass, we've got some macroalgae. We actually have acoustic tagged a bunch of our juvenile greats, and we have at least a pair of them that qualify as resident right near the Nixon sandbar, which is like the place the most people in Miami go to get drunk. And clearly we haven't put them off it because they're still using that habitat, but they use it mainly at night. And they are my favorite favorites, so if you have more questions about them, I'm happy to answer. We know that there are at least 7 species of sharks for whom the Miami area is reproductively important. They are either mating, pupping, gestating, or giving birth here, or spending early years of life here. That includes critically endangered species like the small-toothed sawfish or the great hammerhead. We've got a not quite adult great hammer right there on the bottom, and a nice little baby tiger shark who's probably about 1 year old there on the top.
Do you guys put the hammerheads on Laguna? I went on a trip with you guys 2 years ago, and we caught 2 hammerheads. They didn't put them on closed tag.
It depends on the size of the animal and the condition that it's in. So hammerheads are kind of the most physiologically delicate animal we work with. They're the one that we are the most worried about their well-being. Students help us take samples from the other animals. They do not help us take samples from hammerheads just to keep that work up as fast as possible. My experience is that if the animal fits reasonably well on the platform and can be landed quickly, the workup goes so much faster having it landed that I think it's better for it than staying in the water. But we do catch them up to about 14.5, 15 feet in size, and those animals can't easily be restrained on the platform, and so the best thing to do is usually leave them in. Just to talk a little bit more about our shared home here, Biscayne Bay. Biscayne Bay is a shallow oligotrophic estuary. That's our vocabulary word of the day. Oligotrophic is just a pretentious way of saying low nutrient. So historically, waters in Biscayne Bay had very few nutrients in them, and we have radically changed that through the application of fertilizers and through the ways that South Florida manages water flow. So before people were here, right, sheet flow from Central and northern Florida came all the way down the state in a giant flat sheet of very shallow water. And plants had tons of opportunities to slow that flow, to let any particulate fall out, to take up nutrients that that water was carrying and use them for their own growth, kind of lock them away. And now, especially with agriculture in the center of the state, a lot of waters from Lake Okeechobee are very contaminated with fertilizers. And that means that we're not oligotrophic anymore, or at least not to nearly the degree we used to be. Was it a question?
No, it's just you said arbitrary.
Yeah, I love that. And so when you think about super, super clear tropical water, that it is oligotrophic is the thing that makes it that way, right? Very small planktonic algae can't grow without nutrients. And so when you have that very clear water, nothing will grow in it. It allows maximum light penetration to benefit your seagrasses on the bottom. And it creates this really beautiful clear water quality. And for the most part, the Steam Bay doesn't experience that anymore, certainly not in the northern and central parts of the bay, because of the level of nutrients that we're concentrating into canals and then adding into the Steam Bay. It has likely also radically changed the salinity of the bay, right? In terms of the freshwater pulses the bay receives now are much bigger and more timed, right? We do canal releases when we've had a lot of rain, and we dump a lot of fresh water all at once, as opposed to that water slowly kind of percolating into the bay over longer time scales on land that's better equipped to kind of absorb it. Biscayne Bay is still an absolute marvel, in my opinion. It's a stunningly beautiful place that is making the most of it, even in the shadow of the city, and contains habitats including mangroves, seagrasses, and coral reefs that support more than 30 endangered and threatened species of fish, marine mammal, and bird, among other things. But as we probably all know, South Florida has experienced rapid human population growth, and in Miami in particular, our sewage infrastructure has not kept up. When people ask me what they can do to help sharks, to help marine life, the number one piece of advice I have is go to Miami-Dade Water and Sewer Department meetings, because people don't. And if there is nobody saying, hey, I want Biscayne Bay to be cleaner, I want us to be investing in our infrastructure, they're not going to do it, right? It's not going to be a priority if we're not telling them that it's a priority for us. So septic tanks often leach into the bay, and that's a major problem here because we have very permeable limestone and a very shallow water table here in South Florida. And our sewage infrastructure was originally built for a much, much smaller city than Miami has become. And so we likely need to make some significant upgrades and investments if we want to see Biscayne Bay's water quality return. And then I've just given us a star and an arrow. Biscayne Bay, it's pretty big. The Rosenstiel School where I work is right here on Virginia Key, right by Key Biscayne. So is Nast Academy. And we are all chatting right up here in the Northern Bay, which is sort of the most affected by a lot of the environmentally damaging human activities. And again, a big piece of that is just that you don't have as much water flow with the Atlantic as we do further south. And that exchange has allowed us to dump at least some of those nutrients out into the open ocean instead of containing them all within the bay. So juvenile small-bodied sharks face really complex ecological challenges. They gotta find food, they gotta avoid seeing those. Sharks do not take care of their offspring, with the exception of letting them grow up in utero in some cases, right? Once a shark is born, it's done. That's really different from mammals, right? Tons of mammal species, we think about bears, we think about wolves, right? Mom might be taking care of you for a year or more, you're eating what she's eating, she's hunting for you. You might have a whole pack taking care of you. For sharks, a baby shark is on its own from the instant that it's born. The only thing that mom does for it is secrete an appetite-suppressing hormone so that she's not tempted. Often, a juvenile of the same species depends on different resources, different foods, and different habitats than adults of the same species. So when we talk about conserving lemon sharks, for example, we've got to think not only about what they need in terms of habitat and food as adults, but also as juveniles, right? If the juveniles can't survive, eventually you're going to run out of adults. If the adults can't survive, eventually you're going to run out of juveniles. So solving their conservation challenges can sometimes be more complicated than for species that tend to share more overlap between juveniles and adults, because we sometimes have to think about protection in a more complex way that includes recognizing how it might change over their lifetime. And that process involves recognizing what are called ontogenetic shifts, which is our fancy way of talking about how your body plan, your food, your habitat might all change as you grow. So as you move from being a neonate, a newborn shark, to a young of the year, a shark that was born in the previous pupping season, to a juvenile, a subadult, and eventually an adult, you may shift your diet frequently during that process as your hunting capabilities grow, as you learn better how to hunt, as you have a bigger gauge size that changes what you can fit in your mouth, or as your teeth size changes.
So how big is a neonate?
It depends on the species. We had actually a baby nurse shark born on the boat last year, and it was 27 centimeters.
So, 27 centimeters. Oh, so that is.
Well,
Firstborn, oh, I was thinking they were tiny.
no. This is quite a small shark. I mean, for some smaller bodied species, they might be even a little bit smaller, but they don't get a lot smaller usually than this because they have to fend for themselves from day one.
So they're about that big, and what do they eat?
For a juvenile nurse shark, probably whatever it can catch, but small, fairly slow fish, some crustaceans,
What
some.
about a hammerhead, which is more of a pelagic than a shark?
Yeah, I would say that the hammers, even at birth, are more ambitious. They, I think that a year-old hammerhead would look at a newborn of some other species of shark as a potential snack. And as they grow, actually, hammerheads rely really heavily on other sharks. That's a primary core component of their diet.
Really?
Big hammerheads, bonnet heads, black noses, black tips, all of those could potentially be on the menu. They also really like to eat rays. So I'm going to talk really quickly about a project that we are just wrapping up because we've got some new data in on it and I'm excited about it. But I'm going to go through this fairly fast because I would rather that we have time to chat than that I give you every detail of the study. But here, this is a 34 centimeter nurse shark, so you can see it's pretty small still. Nurse sharks are a common coastal benthic species. They're one of our most abundant catches as part of the Shark Research and Conservation Program. And in general, they're the couch potatoes of sharks, right? They're sedentary, they have low metabolic rates, right? Which just means they don't digest that fast, they don't need to eat that often. They're just lazy. And they interact pretty often with recreational fishers, especially at these smaller sizes for shore-based anglers because they like those near-shore habitats that are pretty shallow and safe from predators. Most of what we know about them has led to them generally being perceived as highly resilient to capture stress. So there was a headline while I was a grad student here in Miami of a guy who took a small nurse shark that he caught, small, to Publix in his pickup truck to try to sell it, and got in trouble with the cops, and they told him he had to go let it go. And he went and released it, and it was still alive. Nurse sharks are very hardy. There was another guy who took a small nurse shark on the metro. It did eventually die, but it survived its metro ride. He threw it in the street on the other end.
What's their primary diet?
They'll eat almost anything that they can find, but they do rely quite heavily on crabs and like slow-moving stuff on the bottom. They'll eat a fish, but it's pretty opportunistic.
So their teeth, they don't really have.
They're more like rays. They have like a crushing plate with very small teeth. So they grind you in a way that you wouldn't like, but they don't have sort of the cutting teeth that a lot of our other shark species have. So when we stress out a shark, they undergo what we call a physiological stress response. And that's just a way of saying like, okay, their body is responding to the experience that they're having in the same way that we might be flooded with adrenaline if we watch a horror movie, right? So sometimes they're responding to a real stressor, right? Okay, there's chemicals in the water, there's pollution, there's low oxygen, I don't have everything I need to meet my needs to operate normally. chemical stressors, physical stressors. I got caught, I'm getting handled, I do not like, but also perceived stressors. So we get stressed out about things that are real and about things that are not real. Same for sharks, right? If you splash and the shark thinks that you might be a predator, it can get pretty freaked out by that, even if there's no actual threat to it. So this all starts with a stressor. A shark experiences a stressor, and then it has 3 stages of response. A primary response, which involves a rapid increase in hormone levels that prepare it for flight or fight, right? I'm gonna run away, I'm gonna turn around and try to fight whatever this enemy is. A secondary response that happens in minutes to hours after that stressor that involves changes in metabolism and immune function as we mobilize energy for that fight or we recover from it. And a tertiary response, that's changes in the whole animal's health or behavior. So, for instance, one of my master's students who works with juvenile nurse sharks caught the same juvenile nurse shark 5 times over a month-and-a-half long period at the same fishing site. So A, the thing is pretty dumb. I gotta say. I mean, nurse sharks are not the geniuses of the shark world. But B, getting caught one time by a recreational fisherman doesn't seem like it's that big a deal to most sharks. But getting caught 5 times a month by recreational fishermen, we can start to see how that imposes some real energy costs on the animal. You know, not just that fight or flight response, because honestly, maybe it gets used to it, I don't know. Our data did not suggest that by the end it was not stressing anymore, but
Maybe it's worth it.
I mean, and maybe it is worth it for the snack, right? Maybe the trade-off of the bait for the hooking does work out for some animals. But we can start to imagine how, over the long term, this might start to limit how much energy you have to devote to growth, for instance, if you're a juvenile shark, right? You're using a lot of that energy fighting the line, you're not using it adding to your body mass. So this is one of my master's students, Catherine Kesey. Obviously, this picture was taken at the height of COVID, so you can see we're still masking up. She caught 27 juvenile nurse sharks, 15 females, 12 males. Between 63 and 153 centimeters, we were looking for animals under 5 years of age that were still using juvenile habitats. In water temperatures from 70 to 93 degrees Fahrenheit, they get pretty hot at the peak of the summer. And when she caught them, she would reel them in as quickly as she could and take what we call a baseline initial blood draw. One of the things that's hard to study about animal stress is like, you can't get their blood without stressing them. So you don't have a value that you're like, this is what an animal should look like when it's not experiencing a stressor, because your data collection is the stressor. But she was able to get that blood usually within 1 minute, and her values were very, very low. And so we think it's a reasonable proxy for a baseline level. And the thing that we are measuring in these physiological studies is called lactate. Right? Lactate is created by the breakdown of energy in the muscles that leads to the buildup of lactic acid. So in many, many studies, we know that lactate is associated with the total fight time. The longer you have an animal in the line, the higher the lactate is going to be when you bring it in and measure it. We know it's also predicted by water temperature. The warmer the water is, the higher that lactate value is going to be on average. And by species, with some species showing a much more pronounced stress response than others, and nurses generally being believed to have quite a low one. We know that lactate is a decent predictor of post-release behavior and mortality. So animals that are really, really stressed out are less likely to survive or are more likely to swim off kind of wonky and need a greater amount of recovery time. Here's that data by water temperature, and we can see that the lower water temperatures are clustered towards the lower lactate levels, and the higher water temperatures tend to be towards the top of those lactate levels. So her findings showed what we expected, right? The hotter the water is, the longer the fight time is, the higher lactate levels are. The master's student that followed her has made that picture a lot more complex. So one of the things that she found was that little nurse sharks could hit total lactate numbers that look like animals that we do not think of as stress tolerant, right? But normally, if you hook a nurse shark, it won't fight you, right? We hook them on scientific gear that's like a weight on the bottom with a hook attached to it. They eat the bait, they get hooked, and then they sit on the bottom. They don't do anything. They just sit there. And then when we come around and drag them up, they are very offended. But they do not actually find the process of being hooked particularly stressful, right? And if we look at our physiology data, they are at the bottom in terms of how stressed out they appear to be by the stuff that we as scientists do to them. But when she makes them fight, right, she was catching them on a rod and reel, and basically she was saying, like, no, you're gonna fight me. They would try to sit down on the bottom, and she'd be like, no. They actually reached levels that are essentially the same as what we see in other shark species. So they may not be that behaviorally responsive to being caught, and that may help limit their total stress, maybe. But what we're finding now is probably not the case. So the next master's student set out to study recovery. And the biggest highlight of his work is it takes more than 8 hours for a juvenile nurse shark to fully recover from being hooked for 30 seconds, right? He would hook them, bring them in, cut the hook, and let them go into a recovery pen. And what he found was that their lactate would continue climbing, often for the first several hours that they were in there, before it started to go down. And so his data is really making this picture more complex for us, in that it looks like it's not that they don't get that stressed out, they just do it more slowly. And so a snapshot of their stress at the time of capture hides how stressful that experience is for them overall. And we're actually seeing the same thing in water temperature, where his individuals caught in colder water, their stress response starts slower, but it peaks at the same height, right? So it's not actually that colder water makes them less stressed out, it's that colder water delays that stress response in a way that means that we as scientists tend not to capture it. So this paper is going to make a lot of shark physiologists really angry, which is something that I'm actually stoked for, but it's going to be a bit of a fight when we get there. Very quickly, what else are we up to? We are studying pupping and growth rates in juvenile sharks and their mothers. We're studying juvenile habitat use, how stress affects animals across species, age, and size classes. So it does look like adult nurse sharks might be a lot more tolerant to stress than the juveniles are. Mating and gestation behaviors, and the effects of climate change on nurseries. My personal biggest fear is that I'm going to end up being the scientist who reports the first nursery to fail in response to climate change. We have an important flag-tip nursery here in Biscayne Bay. Here's one of my little neonates. He's still got his throat button, which tells us he was born less than 2 weeks ago. But we're seeing increasing parasite rates in those juveniles that I think may be associated with warming temperatures, and increased rates of starvation. So Biscayne Bay, as it warms, is going to be less hospitable to these juveniles than it has been in the past, which is one of the reasons why I'm personally so motivated to try to address some of the challenges we can address, like water quality, since one of the best ways we can buffer effects of climate change that we don't control is by reducing other stressors and improving overall habitat quality. And here's one of my baby gray hammerheads, because I couldn't resist throwing him in there. Just so that you can see it, I brought a nurse shark ultrasound. You're going to be able to see a little nurse shark's face right there, opening and closing his mouth. He's got some siblings that we're looking at side on, right? Those long streaks are their spines that are getting picked up by the ultrasound, moving around over here. But he's the one who's really going to give us a show. So we're using ultrasonography to try to not only determine that sharks are pregnant, but also start to get a sense of what the important gestation habitats within the bay might look like. Nurse sharks, you'll be unsurprised to hear based on what else we know about them from tonight, are willing to gestate pretty much anywhere. They're not too picky. That is what I have for you. You can connect with us on our website or obviously on Instagram or Facebook. That's my email. I am delighted to take any questions that anybody has.
Commercial fishing, what's the current, does it like vary by state, or what's the current limits for commercial fishing for sharks in Florida and US?
It varies a ton. So we have some species that are managed and some species that are unmanaged. In Florida waters, it's 1 shark per day, per person, but there's also a boat limit, so I think it's 1 per person per day. But if you're on a boat, then it's maybe 2 per boat.
That's commercial or recreation?
Recreation.
Is there commercial, is there any commercial side?
There is some commercial fishing for sharks in Florida waters, but it's pretty limited. There's just not a huge market for it. It's more likely to be a side gig for somebody who spends most of their time targeting something more valuable. That's one of the reasons the recreational fishermen are very worried that shark populations are increasing, because they're seeing increased depredation. You know, is this a giant shark boom? And I can tell you that from our data, it does not appear to be. We're seeing some population recovery of sharks, but I think more of those conflicts have to do with population declines of popular prey fish and fish that humans like to target and eat. There's a lot of overlap between the fish we would like to eat and the fish we would like to eat.
So is that why you see so many more amphibians now, especially?
More sharks? Well, the Bahamas has been a shark sanctuary since the 90s.
It's true, but now you can literally like see them. Before, they were there, but.
Well, some of that, I mean, if you're thinking about like around Bimini Big Game and stuff, some of that is that they feed them.
Oh, of course.
So like the bull sharks hang out there
Yeah.
because they get fed. They wouldn't be there otherwise. And the same is true for like the reef sharks down by Triangle. They get fed pretty regularly, and so they show up, and probably for tigers and hammers around the great area, the places where they're doing those hammer dives, they're feeding them. So I think that they're more tolerant of people than they used to be. I don't think there's necessarily a lot more of them than there used to be. We just are seeing them more because they're coming into contact with us for that feeding opportunity. So different rules govern in federal waters than in state. In federal waters, there's a whole complex suite of shark fishing regulations that's mostly species or group based. And sometimes there's different rules, like federal rules apply in the Florida Keys National Marine Sanctuary, which is inside state waters, but it's federally managed, so federal rules apply there, just to keep everything nice and complicated.
Finning is what really impacted the shark population. Yeah, they really clamped down on that a lot.
Yeah, so finning was a big driver of population declines, especially, I would say, 20 years ago. It's been falling in importance. The global trade in fins peaked in 2003. But meat has kind of revved up to almost match it actually in value. Obviously, per pound, fins are vastly more valuable, but if you catch a 200-pound shark, a pretty small fraction of that weight is fins. So in many places, shark meat has been introduced as a replacement for fish that are less available than they used to be. Shark gets used pretty often in fish and chips in Britain and Australia. There are particular kinds of shark, but yeah.
I didn't mean to, yeah.
Sorry. I mean, a well-prepared shark, I'm told, can be delicious, although when I've had the opportunity, I just didn't have the heart. I was like, I can't go back to work next week and be like, I know what it tastes like.
So you're saying there's no merit in what we have heard over the past year from recreational fishermen who are diehard guys who say that there's more predation on their catch than there's ever been in their lives.
I believe them. I mean, I think that often fishermen are a very good resource to hear about what's happening. I can tell them that from fisheries independent surveys that scientists are doing, the reason for that is not that shark populations have radically changed, right? Like our data does not support that. And we're out there fishing in a standardized way to try to study population trends. So we would probably be catching it if it was happening. So something is driving this increased conflict, but it's not.
They're not as good as they think they are.
It's not the number of sharks.
or the fisheries failing, so there's the pressure on the fish that are.
I think reduction in the number of available fish is a better explanation. I think that there's some possible explanations around shark metabolism being tied to water temperature. It's hotter now, they need to eat more to meet their essential needs, and so they may be a little more hunger motivated than they have been in the past. In some cases, they're really used to fishermen targeting the same spots over and over again, and like if you tend to get an easy meal there, you just kind of get used to going back. So I think that there's probably a mix of possible explanations, but from what I can tell, it's not overall that shark populations have radically increased. We're seeing some population recovery, especially in like black tips, but it's not a dramatic trend. They do want to shout at you when you tell them that. I know that from experience, but I mean, all I can do is offer the data. I believe in that it's a bigger problem than it has been in the past, and I'm concerned about it, but I don't think it's because there's a lot more animals. I think less fish is a more likely explanation.
So we came for sharks or fish.
Sharks?
Sharks did.
I mean, sharks are fish.
What did early sharks, oh, so they're in the fish family?
Yeah.
So, I guess what did early sharks eat then?
Lots and lots of invertebrates. There were other fish that are not direct. Yeah, there's a lot of other organisms that are not directly represented today in our evolutionary lineages, right? So like we have placoderms, like armored fish who have no direct descendants today, but who were present in ancient species. And also, actually, sharks came in a much larger range of sizes back then than they do now. The megalodon, yeah. So you had megalodon, but we also had schools of sharks like that were all this big, right? Where they occupied spaces that today are occupied by mullet, right? Schooling bony fish. So they
I was
ate
in the
up.
Keys nautical show, and there's a woman there selling shark teeth from megalodons, giant shark teeth like this big. She says her husband goes out off of North Carolina to the 100-foot ledge, and he sees it right on the surface there. So you've heard about that too.
I didn't know that specific location, but yes, people do
he goes
find
out
them.
there, and he catches it. He comes up with like a bucket full of these teeth, 100-foot water, so right off North Carolina.
That's cool. I get asked if megalodon is real. Megalodon is real. Megalodon is extinct.
Well, these teeth are this big. These teeth look very real. Yeah.
I'm very confident about both of those statements. If we had
a pretty convincing movie, right?
if we had a 40-foot shallow water predatory shark, somebody would have felt the footage of it.
Up to 60 foot long.
And people will be like, but what if it's a scientific conspiracy? You can't get us to agree on what to have for lunch. There is no we're working together to hide megalodon.
How common is the coral bleaching phenomenon in South Florida, and does it represent a problem for sharks? Are sharks affected by coral bleaching?
I mean,
I guess so.
yeah, so for anybody who has not been tuned into it, last year was the worst bleaching year we've seen in a really long time. 70–80+% of the corals that we had remaining, which is what we would call a remnant population of our historic reefs, bleached, and most of those that bleached died. We're approaching game over for coral, at least here on the northern extent of the Florida Reef Tract. We're creating conditions in which they can't live. They're at the bottom of that food chain, not the very bottom, but close to it. So thinking back to bottom-up control of ecosystems, where you lose those reefs, you lose a lot of biodiversity and biomass and species that depend on those reefs for food or for shelter. But a lot of those changes here in South Florida have been underway for decades, right? You look at pictures of our reefs from the 60s and 70s, they're unrecognizable compared to today. This bleaching phenomenon that we've had lately, it feels very sad to me, and honestly, I kind of walk around the Rosenstiel School feeling sorry for the coral scientists a little bit. But it's the last straw, not the first in a collapse of our reefs, at least up here in the Miami because we've put so much strain on them for so long. So I think for my sharks, it's not going to be a huge change overall. I mean, they've weathered this happening for the last 40, 50 years. But I don't think that it's good overall for the ecosystem for sure.
Our words never stop.
Let's do a question less depressing, even if we're wrapping up. Coral death, because I don't want to end there.
Hammerhead sharks have a very unique head. Why do they have a unique head and how come just hammerheads and not sharks?
I love this question. So the answer is scientists can't agree on what to have for lunch, so we can't agree on why they have a dorso-ventrally flattened head either, but we have some theories. So one is it generates lift as they swim, and we know that it does to at least some degree. One is that it distributes what are called their anculi of Lorenzini, their electromagnetic sense that happens through tiny gel-filled pores in their head and face. It lets them spread them out so they can swing that head like a metal detector, have a wider field of detection for potential buried prey, which makes sense if you really like to eat rays. It has some maneuvering capabilities, so if you ever see a hammerhead hunting, they're capable of these incredibly tight turns for their size, even compared to other flexible sharks. I mean, there's nothing else like them in terms of maneuverability, and some of that probably has to do with the head, but it's probably a mix of all of them, and there's no universal agreement about it. I mean, and there are also 9 species of hammerhead globally, so it's an adaptation that has worked for different of them, although the shape and size of the cephalofoil, which is the science word for the head, varies depending on the species. Some of them are pretty small, bonnet heads, right? They're in the same family as the great hammerheads, which get up to 21 feet. I've not seen one that big, but they do get quite big.
Is that a convergent trait, or are they evolved?
They are related. It hasn't evolved separately in multiple species, at least not as far as we know.
In your opinion, like, what's the most unique like shark, or most interesting shark?
There are so many weird sharks, which is the thing that I love about them. When I'm asked my favorite shark, I have a contractual obligation to say the blue shark, and the reason for that is when I was just out of college, so like not that much older than you, I was doing research in South Africa, and it's the only time in my entire career I've ever gotten seasick. And I leaned over the side of the boat and I threw up directly onto a blue shark's face. And I was like, I am so sorry. Forever I will tell people of your beauty and grace. And I do. They're very lovely. But of the animals I work with, my favorite is the great hammerhead. I just feel like you can't talk. And especially the babies, where like their proportions are a little bit wonkier and they have these big eyes. And the pictures do not do them justice because they're actually this like very beautiful blue, purple iridescent. Yeah, he made that face. He was not ready. He actually didn't seem very bothered, but I was mortified. So I'm still making it up to him.
Where did you learn that?
In the Bahamas, at Stewart Coves in Nassau when I was 20. Yeah. No, I mean, people are like, I didn't start diving when I was 5. Can I still be a marine scientist? Yes. Yes. Never too late.
Thank you.
Absolutely. It was my pleasure. If anybody wants to ask the last question as you leave, come find me. But thank you all so much for being here. It was lovely. Please do feel free to connect with us in whatever way makes sense for you. We're on Instagram at Shark Tagging. It's probably where we're the most active on social media.
And if you see our posts on social, I tag them also, so you can go, if you follow us on Instagram, go and look at the posts we made on there. You can find it there.
Thank you, Catherine.
Yeah, absolutely.
So it sounds like there's still like, you're not native, so if you're giving her some, They sound like.
Oh, no.
Thank you.
Thank you, bye.
Thank you.
I know.
Thank you so much. I just have a question on the conversion trip, and I'm actually a comments for a couple of thoughts, but I'm just curious about students as a
So what are you thinking about applying to do?
So I'm applying to the program, yes, program. I think I'm going to apply to Porter. To me, that makes it kind of safer. What I'm learning.
I mean, most of my students are MPS. I've got 5 PhD and 12 MPS
Oh, wow, okay.
students. But usually for the MPS program, I'm the track lead for the marine conservation track. So if you apply to the marine conservation track, you will end up having to deal with me. But also if in your application you say that you're interested in sharks, those students tend to get assigned to me as their academic advisor. And then if they want to do their work with me, the application for that is in spring. So you get a semester under your belt before you start figuring out what lab you'd want to work in or where you'd want to go.
Okay, thank you.
Yeah.
Tomorrow.
Oh, cool.
Thank you.
You may bump into me on campus. I might be running around.
Sounds good, thank
It
you.
was so nice to meet you.
I'm not part of
Unfortunately, they mainly make me limit who I can work with to how old are you, what are you doing, and
I'm 19 and studying biology, hoping to go to vet school. I'm very interested in animal behavior though. That's one of the main reasons why I wanted to veterinary medicine. I think it's a lot. I want to do exotics specifically just to see all the biodiversity and what's pretty interesting. I'm very interested in conservation as well.
to get you. That's awesome. Usually I'm not allowed to take interns from outside the university. There are occasions, if you shoot me an email, I'll put you on the list. We have a list we maintain of like if we ever need to fill our staffing needs from our students, we'll like send out a call to this list. Out in the last year.
Yeah, I also got the undergrad. I got
We haven't read that. Yeah, so I'm happy to add you to that list, but again, like the odds that it ever happens.
Yeah,
are
very
low.
Okay, thank you so much.
Yeah, absolutely. It was a pleasure. Good luck with the vet school process as you start to move back down to city school. It's a whole thing, I know.
Also in squirrels too, so we are going to possibly take owls and foxes. Bye. Bye.
If I pull this, am I gonna cause a problem?
Oh, yeah, sorry, let me.
I just don't wanna.
No, you're good, you're good.
Make the computer angry.
Where was the pictures then?
There